So this video is a review of some things that you should already know about exponents, and if you don't already know them, well then it's going to be an introduction to exponents, or you may have forgotten them and it's going to be a refresher of your memory. So remember that an exponent or a power is just a repeated multiplication. So it's a number that, so if I say 2 to the exponent of 5, I mean 2 repeated 5 times. Powers can be written in exponential form. So 2 to the exponent of 5 is exponential form. The answer of 32 would be called standard form. The base, that will be the larger number in the power, and that's the number that's being repeated over and over again. And the exponent, that's the smaller number in the power. That tells you how many times you're going to be repeating that base over and over again. So what I want you to do is maybe pause the video for a second, see if you can figure out which one of these words relates to each of these 6 arrows. So pause the video, figure that out, restart it to see if you're right. Okay, so here are the answers. So as I said, standard form, that's just a fancy way of saying what does the power equal. Repeated multiplication is writing out how many times does the base get repeated. So 10 to the exponent of 6, the base of 10 gets repeated 6 times. You just write that out. And then the power would be the simplified form of the repeated multiplication. So whatever number gets repeated, you write at the bottom as the base, and however many times it gets repeated, you write as the little number at the top as the exponent. And that whole thing is called the power. So down here, same thing. What we tend to get confused with was we say 10 to the power of 6. Technically, that's wrong because the whole thing is the power. So we should be saying 10 to the exponent of 6. So 6 is the exponent, the base is 10, and the whole thing, 10 to the 6, that whole thing is called the power. So let's look at some examples. So how would we express 2 times 2 times 2 times 2 times 2 as a power? So again, you just have to look and you have to say, okay, the base, the number that's getting repeated is 2. How many times is it being repeated? It's being repeated 5 times. Now this next one is a little bit different. It's asking you to write a number as a power of something. So what that is telling you, when it says power of something, that's basically telling you base is 5. That's really what that's telling you. When it says power of, it's telling you that the base is 5. So then you have to do a little bit of playing around or guessing and checking or using your calculator to figure out 5 to the what is 625. So you might try 5 to the 2 and realize that, oh, nope, that's 25. Or 5 to the 3 and see that that's 125. If you keep sort of playing with a little bit of knowledge, you're not just completely guessing, you're going to find that 625 as a power of 5 is 5 to the 4. What you're going to find with powers is that they get really big really fast. So even though 625 is a big number, you wouldn't try like 5 to the 10. 5 to the 10, if you tried that on your calculator, it's going to be huge. And then this next one, 2 to the exponent of 7, all you need to do is punch the base of 2, find the exponent button on your calculator, and punch 7, and then it will give you an answer. And so when you do that, you're going to get 128. Now, before moving on, just take a moment to see if you know how your calculator works. So on your calculator, you're going to be looking for a button. Your button might look, whoops, erase that. Your button might look like this. So you might have a button that looks like that. Or same thing, but different letters reversed. So you might have a button that looks like this. You might have a button that looks like this. Those are typically what the 3 exponent buttons look like on a calculator. You may see a button that looks like this. That is not your exponent button. Most people's calculators, you hit the base first, then the button, then the exponent. Some people's calculators you have to press equal. Some people's calculators will immediately give you the answer. So I want you to take a moment just to make sure, for example, 2 to the 7, that you can figure out how to do that on your calculator. You should not be punching in 2 times 2 times 2 times 2 times 2 times 2 on your calculator. You have a calculator. You are allowed to use a calculator. Use it to make your life easier. If you don't know where your exponent button is, please call me over and I will come and I will help you find it because it's really important that you know how your calculator works. So one other thing that you did do in previous years was a factor tree. And so you can take the number 144 and start breaking it down. There's lots of ways you can break it down. You can break it down into 12 times 12. You can break it down into 2 times 72. It makes absolutely no difference how you break it down. All you have to do is find one number that goes into it and then figure out what the other number, so for example, if 2 goes into it, figure out how many times 2 goes into 144, and then you have your two numbers. I'm going to start with 12 times 12 because it's just going to make a little bit of a smaller factor tree. Then you break down each of those. So I'm going to show you two examples. For example, you could break down the first 12 into 3 and 4, and you could choose to break the second 12 into 6 and 2. So it really doesn't matter. You're going to end up with the same answer. Now, because 3 is a prime number, you're done. You don't have to keep going with the 3. 4, however, you can keep going. So you're going to break the 4 down even more. The 6, again, you could break that down, but the 2 you cannot. Now, if you look, you've got a 3, a 2, a 2, a 3, a 2, and a 2. Those are all prime numbers, so you know you are done. So if you had to break the number 144 up, you would say that 144 was equal to 3 times 2 times 2 times 3 times 2 times 2. That's kind of a pain to write that all out. We now know more about numbers. We know about exponents. Why not use that to our advantage? So this is what we want you to be doing. A little bit different than what you did last year. So how many 3's do you have? Well, if you look, you have 2 3's. Well, how do we write 3 times 3? It's a lot faster to write it as 3 squared. Likewise, how many 2's have you got? You've got 4 2's. So it's a lot faster to write that as 2 to the exponent of 4. So this here in blue, this is what we want you to be writing when you break down a number into its prime factors. We don't want you to write them all out. We want you to write it in exponential form. So let's look at one more. Again, you can break 250 down into many ways. You can do 2 times 125. You can do 5 times 50. You can do 10 times 25. It makes no difference. So I'll do 10 times 25. You might have chosen something different. Doesn't matter. Then break each of those down if you can until you don't have any more composite numbers. So looking at this, these are all prime numbers. I know I'm done. So if I were to write 250 out, I have to look and I see, okay, I have 3 5's. So I'm going to write that as 5 to the exponent of 3. I have 1 2, so I'm just going to write that as 2, or if you want, you could write it as 2 to the 1. Again, that's going to be your answer. That's how you're going to break it down into prime factors.